Okay, guys, today we're going to be talking a little bit more about application of arc length. So we're going to be using that arc length formula. For those that don't recall from last week, the arc length formula is arc length equals the angle of rotation multiplied by the radius. Okay, and our angle of rotation will be in radians. All right, let's share this example. If the radius of the pulley is 10 centimeters and the rotation angle of the pulley was pi over 4 radians, how high will the height rise? Alright, it might sound a little complex, but let's picture this pulley. Let's look at this picture over here. As this pulley, let's say it's rotated this way. Alright? As it's being, it's bad arrow, but as it's being rotated, in this case counterclockwise, as it's being rotated, this weight is going to be moving up. Because as this gear is being rotated, this cord is going to wrap itself around the circumference of the circle. So as it gets rotated, the cord is going to be coiling up around this gear. As it's kind of wrapping itself up, this gear is rising, this weight is rising, right? To determine how much this height rises, we can look at the arc length, because how far this height rises is the equivalent of that arc length. So let's say this is our example over here. As this gear moves up, the cord is going to wrap itself around that arc length, or the arc length of that little section there. How far the height rises is equal to the arc length. So all we have to do is find the arc length. All right, let's look at what we have so far. If the radius of the pulley is 10 centimeters, so we know the radius, and we know the angle of rotation is pi over 4. So my arc length is equal to theta times r, or in this case, arc length is equal to pi over 4 times 10. Doing our math, we get arc length is equal to 10 pi over 4, or we could simplify that to be 5 pi over 2. This is our arc length. Oops, sorry, I was off screen a second. That's our arc length. Now, our arc length, let's just say we get into decimals. We'll just do kind of an approximation here. So our arc length is approximately 7.85 centimeters. That's how high the height will rise, or the weight will rise. Because if the arc length of this little section over here is 7.85 centimeters, that means the weight, the string holding the weight, is going to wrap itself around this gear. It's going to wrap 7.85 centimeters of that rope will wrap itself around the gear. So the weight will have to rise the equivalent amount. So the height will rise 7.85 centimeters in this first example. In our next example, we have this situation, we have two gears kind of locked together. And as these gears, they're locked together, right? So as these gears start rotating, right, they're going to rotate with one another. So we'll read the example. It says two gears are locked together by their cogs or teeth. When one gear moves, the other moves as well. While the two gears of different sizes rotate different amounts due to their size, what they do have in common is the amount of arc length that is used while they turn. So these are going to spin different rates, right? If you ever see a machine run, that smaller gear is going to turn faster than that larger gear, okay? But they're going to be turning each other in part. But the arc length, or the amount, the distance, right? Arc length is like a distance, the distance that is turned will be the same in each gears. There are two gears, one with a radius of 6 centimeters and the other with a radius of 24 centimeters. So this is the radius of my smaller gear and the radius of my larger gear. If the angle of rotation of the smaller gear was 2 pi radians, what was the angle of rotation in radians of the larger gear? So remember we said the arc length will be the same. So that's a very critical part for these type of problems. The arc length will be the same. So let's look at that small gear first. In the small gear, my arc length is equal to my angle times radius, same thing as before. But my arc length in this case, we know what our angle of rotation is, 2 pi radians. And we know my radius, 6. So my arc length is 12 pi centimeters. I'm not going to round for this one because this isn't really my answer. But when we're going to round, we'd round at the end. But my arc length of the small gear is 12 pi centimeters. That means that distance traveled, because it's the circumference, the distance around a circle. The distance traveled by a gear rotating will be 12 pi centimeters. Well, as the small gear rotates, so does the larger gear. And the arc length has to be the same. So this larger gear will also rotate 12 pi centimeters. So this arc length will be the same arc length of the large gear. Think of that, they're interlocked with one another. The amount of distance that this one travels by rotating can't exceed or be less than this because they're interlocked, but they gotta spin one another. So it has to be the same arc length. So knowing that my large gear has an arc length of 12 pi, it also has a radius of 24, we simply don't know the angle. So we don't know this theta, right? We're solving for theta. Well, all we have to do is divide both sides by 24. And we get pi over 2 equals theta, right? And just for clarification, that is an angle. So we have pi over 2 radians. So that angle of rotation, as the small gear rotates at an angle of rotation of 2 pi radians, that means it's a full circle. So as that gear rotates all the way around, that's because 2 pi is 360 degrees, it creates an arc length of 12 pi. Well, the large gear is going to rotate the same amount of distance, 12 pi, but it's only going to have an angle of rotation of pi over 2, which is about 90, which is 90 degrees. So it's not going to have the same angle rotation, however, that arc length is the same. Okay guys, good luck on the practice. Message me if you need any help.